So let's see. Form of the information determines the type comments. Type comments determine the template. Template determines the form of the functions. Then when we have repetitive functions, we can abstract them into an abstract function. Could there be a way to shorten that route? In fact, there is. In fact, there's a way to go from type comments directly to abstract functions. And then lots of the functions we write just become very short. We're not going to take quite that shortcut in this video. What we're going to do in this video is go directly from templates to abstract functions. And that will take us all the way back to something we saw when we first looked at list functions. Remember the table of list functions, and we just looked at what to fill into each position in the template? Now what's going to happen is lots of our functions on lists and arbitrary arity trees or any other kind of recursive structure are going to get real short, and generating the abstract function is going to get real automatic. I'm in fold function starter.racket, and at this point in the course, the type list of x means list of x is one of empty or cons x list of x. And we interpret that, what is there to interpret it as? A list of x. And the template for list of x is the ordinary list template. Two cases con, if it's empty something, otherwise the first of locks, fun for locks, rest of locks. And I've renamed the parameter to locks because it's a list of x. And now here's a problem. And the problem is to design an abstract fold function for list of x. So you might ask, what the heck's a fold function? Well, let me show you. Here's the idea. The idea is to design an abstract function based directly off the template. So again, I'm going to work backwards through the steps of HTDF. I'm going to copy the template, and I'm going to call the function fold. It's actually going to be the foldr function, but I'll just call it fold. Then I'm going to say, gee, there's two sets of dots. I'm going to introduce one parameter for each set of dots. And I should give them some good names. Now, this one is the base case result. So I'll introduce a parameter called b, and I'll use it in this position. Notice I'm also getting rid of the parens, because b is the final result. It's not a function of no arguments. So there, b is now standing for the first set of dots. And this one is a function that's called to take the first of the list and combine it with the result of the natural recursion. So I'll call that fun. And just by convention, we put the function arguments early in abstract functions. So I ordered the arguments that way. You could have ordered them the other way. I just want this to end up being exactly like foldr. So now I've got the function. Now I've got the function. Now let's do some tests for it, some check expecs. Well, it's the abstract function for the list template. So I know some of the things that it can do. If I say fold with plus and 0 and list 1, 2, 3, I get the sum of that list, which is 6. If I say fold with times 1 and the list 1, 2, 3, I get the product of that list, which is also 6. And I could try those to make sure I understand this function properly. Oh, what happened here is I forgot to rename the recursion, and I forgot to add the parameters to the recursion. Huh. You're always making mistakes in this business. Now I've renamed the natural recursion, and I added the parameters in the natural recursion. Now these tests are tests from later in the file, so we're not going to worry about them. These failing tests are from later in the file. Let me comment that out so we won't see that ugly highlighting. My tests for fold are working. So now what's the purpose? Well, if you didn't have a more abstract way of writing the purpose, if you didn't know that this was fold_r, it would be enough to say the abstract fold function for list of x. Because that's what a fold function is. You take the template, you define a function based on the template with an additional parameter for each set of dots. And that's what a fold function is. Now let's think about the signature. Well, you know that this isn't, even though both of these examples are list of number, it started with the list of x template. So you know that this third parameter is really list of x. Now, this makes it quite clear that the result isn't list of x. It isn't even a list at all. It's something else. Now, it happens to be number in both of these cases, so you might want to just put number there. But what you should do instead is think, can I make it do something else? Can I make it, for example, quote, add up some strings? For example, can I do fold string append with the empty string as the empty sum, and list A, B, C, D, E, F. Let's see, adding or appending all those strings together should produce A, B, C, D, E, F. And that test is working. The test that's failing is later in the file. So that test is working. So that tells me that the result isn't always a number. It can be something else. Now, in both of these cases, it's list of string to string. So that might make me write x there. Now I got to try to make it do something else. I got to see, can I construct an example where the final result isn't the same as the type of the elements of the consumed list? So you could try to construct that example, or you could look at the code and say to yourself, well, each of these has to be an x. Those are always the type of the first argument of the function. So let me back up here and say the first argument to the function has to be an x. The second argument to the function is the result of the recursion, which of course is the type of the base and always the result of the function. There's nothing here that says that this type and this type really have to be the same. So this could actually be y. And then if this whole thing is going to produce a y, then that means that the type of the second argument to the function is a y, and the function has to produce a y, and also the type of b has to be y. So what that says is, give fold a value of type y, the base case value of type y, and a list of x, and a function that consumes an x, a y, and produces a y, and it will go through the entire list producing the final y. And that's in fact the signature for folder. Now that you have fold, if you didn't have it already, but now that you have it, you can of course use it in lots of ways. You've already done some in an earlier video, so I'll just pause here and ask you to do it again if you're a little unsure about how fold is working, just to improve your confidence that you understand what fold does.